Happy number. So a happy number is a number defined by the following process. Start with any positive integer. Replace the number by the sum of the squares of its digits. And we're going to repeat the process until the number equals 1. So apparently there could be a case where it will never equal to 1 and it will end up looping. If the number actually comes down to 1 after we keep applying this process, then that means the number is happy. Otherwise, it's not happy. So we're gonna return a Boolean variable. If it's happy, then it's true. False, otherwise, right? So let's take a look at one example. So if the input is equal to 19, so the very first thing you're gonna do is take the first digit 1, apply the square plus the second digit square. So that's 1 square plus 9 square is equal to 82. Right, so we're gonna then apply the same process, take 82 and then do a squared plus 2 squared, and that takes you to 68. So we keep doing the process until we eventually equal to 1. And if that's the case, that means this input is true. That means it's a happy number, right? So how do we tackle this problem? Let's well, it seems like it's a pretty classic example where we have to repeat the same process over and over again, right? So it will be helpful if we have a helper function that can basically be very generic, and it would just take any integer and apply this process and return the sum of the squares, right? And so in order to do that, let's first code a helper function. So this function is going to be returning an integer. It's going to be the sum of the squares of all the digits, right? So let's just call this helper. Apparently, it's going to take an input, and notice that this one and this one are different. Or actually, let's call it a different number. Let's call it integer t, right? So we're gonna say first result is equal to 0, and eventually we want to return this result, right? So we want to keep applying the same process, right? So you'll notice that if we satisfy these conditions, the input n, right? So first is 82, and then 68, then 100, and eventually equal to 1, right? So we're gonna say while t is greater than 0, because if the theory is right, if it's actually a happy number, eventually it's going to come down to 1, right? So let's see. First, you want to take we can go backward, right? So if you take any input integer, say 82, right? So how do I get the last digits? So that's 82 divided by 10, that's equal to 8, right? With the remainder of 2. So that's actually 82 mod 10. So you take the remainder and you divide 82, divide the number by 10 and take the remainder, right? So we're gonna say this last digit d is equal to t mod 10, right? So this is gonna take the last digit and then you add this to the result. So, and remember at this point, the result, if we keep doing the process, could already be holding some values, and the value will be the sum of the digits counting from right. So it should already have some value. So we're gonna add, that's why we say add equals d times d squares, right? And then we're gonna have to update t, and t is equal to divide equal to, so basically t is equal to t divided by 10, right? So all right, once we have this helper function and we can think about this, so there could be two cases, and they already told us, right? So there could be two cases. Number one, you repeat the process until the number equals 1. Secondly, it will loop endlessly in the cycle, right? So that has made the question a lot easier, because we only have to deal with these two scenarios. If it equals 1, that means that's a happy path, and otherwise it could loop endlessly in the cycle. And so for example, you apply 82, with the process, and then it takes you to 68. For example, let's assume that the 68 comes back to, you apply the process, it comes 82 becomes 68. Let's assume that you apply the process at 68 becomes 82. It will just keep looping, right? So how do we detect these scenarios? You may think that, okay, so we may need a hash set where we're storing the values already encountered. And that way, every time we apply the process, we can check if previously we have encountered this number before. If that's the case, then it's never going to reach the number 1, right? So because if you encounter 82 again, you have to apply the same process that takes you to 68. You just keep looping, right? So you never take you to 1. So first off, we're gonna define a hash set of integers. Let's just call it a set equals new hash set. And this is going to store all the values we have encountered in each step. So while n is greater than 0, right? So classically, we're gonna say n is equal to helper of n, right? So, but we do have to add the check here for duplicates or for loops, right? So so every time we're gonna be adding set.add this to the set. Every time we're adding the value. However, we need to check before we add or before we even update n, we need to check if we have already encountered this before. So if n is greater than 0 and the set does not contain, so we're going to say contains n, and then we're going to negate this, right? So if the set doesn't contain n, then go ahead. Otherwise, we're going to return false. So eventually, what's going to happen is we're going to say return n is equal to 1, whether n equals to 1 or not. So if the set contains n, it's not going to go into the while loop anymore. It will jump directly to line number 8 and evaluate n if n is equal to 1 or not, right? So let's run this. Okay, I'm missing a semicolon here. All right, there we go. So that's a pretty classic, and you may want to remember and this helper method because it's a pretty classic example of how to get the sum of the squares, and you can apply the same logic to a lot of problems.